And then the recording as well. Now sometimes when I leave, I forget, so you need to remind me. Okay. So data structures. Now, let's go to data sets. So click over here. In your system library, you see data sets. Let's go through. So these are real data sets in R. Okay, so let's look at, there's infertility after spontaneous and induced abortion. So let's look at what data, so that those in second, who is teaching here? Maybe you can use it to advise a secondary school student. So let's use so the data name is what? Infert. And it talks about infertility after what? Spontaneous and induced abortion. So this is a match control study dating from before the availability of what? Conditional logistic regression. Okay. So let's look at the format. So that's the description of the data. Usage. So this is very important. If you want to use it, they say just call it. Use infert. The format, education. 0 means 0 to 5 years. Okay, yeah. That's your education. Okay. 1 is 6 to 11 years. 2 is, what kind of data is this? The 0, 1, 2, what are they? Okay. They are categorical data. So education is categorical, right? Okay. Why is it so? They are in distinct group, yes. You cannot be having education 12 plus years and at the same time your education, the length of your education is only 2 years. Something like that. Okay. Then age. Age is what? In years of what? Case. Then we have parity. Number of prior induced abortions. Case status. Number of prior spontaneous abortions. Mass set number. Stratum number. What is a stratum? What is a stratum? Groups within the population. There's a characteristic. Within the groups, what? What is homogeneous? They have what? Similar characteristics of the group. Good. Okay, so we'll be, the statistical terms, once we get to, we will also try to explain. So this is a real data set, and it was published in what? The British Journal of what? Obstetrics and what? Gynecology. So these are data sets that you can even use for your project. Very soon we will be giving you supervisors for your project and so forth. So instead of going to organizations to now Ghana Health Service to go and get that data, you could as well use a data set from her. Is that okay? But sometimes you want practical aspect of it in relation to current problems. Or maybe you want to be able to compare what was reported here and what is currently happening in Ghana. Then there's a need to also get data from. But remember, it's time bound, right? If you want to graduate next year, so that I think I will graduate next year. So if you use 1 year to chase Ghana Health Service to get the data, when are you going to do your analysis and write your book? So those are some of the things. So we can get data, a real life data set in here. So then this is real. Okay. So this data set, we can check its structure. So structure, we use the function str. And then we put the structure of the data in there. And this is how the structure looks like. It says it is what? A data frame made up of what? 248 observations of what? 8 variables. Okay, so that's it. Now, there's also a data set called State X77. So let's look at that State X77 and look at its structure. So State X77 is numeric, and it has 50 rows and 50 columns, 8 columns. So we're going to look at all these as structures of data. So A, the first data structure is called a vector. So a vector is a one-dimensional array. So what is a one-dimensional array? It's just one variable. Then you get responses to it. So for example, if I say age, and I want 5 people to tell me their ages, do you want to call your age? 20, and you are here. 27, 25, 34. We want 5, and the last one, 29. Okay. So vectors are constructed with. Did I talk about help? Did I talk about help when we were talking about the interface for RCD? We did not. Question mark. You've seen the question mark. So question mark is help. Is that okay? Okay. And then the double one is also help. The first one, the single question mark, will search through the packages that are loaded in the environment, right? The double one will search through all packages installed in your RStudio. So the double question mark is a deeper search. I will demonstrate this. Let's move on again. But question mark is help. That gives you information about the data. So I'll use a single one, and then I'll also explain the. So the small letter C is what is called, it's in the base package, right? Remember, base is in what? The system library. That's the first package. So it uses some of these simple commands that we use to create data. So C is in the base package, which means you cannot name your object with the name what? Or with the letter C, small letter. Capital letter is different. Is that okay? Good. So what this function does is that it combines values into what? A vector or a list. So the first thing we are doing is what? The vector. Okay. So what this means is that it is going to combine these values into what? A vector. Now, what is this? What is all the assignment? So it means that what is on our right hand side will be combined into a vector, and it will be named what? Age. Is everybody okay with this? Okay, good. So now let's run this. And age appears in what? Our environment. Please, is everybody okay with this? You see, as soon as you write it, you see it over there. Now, age, you see also noun, which means it is numeric. So the type of data, the structure is a vector, and the vector contains what? Numeric values. So that's the data type. Please, is everybody okay? So the structure will just be like this room, and then the objects in, we can have human beings, there are fans, lights, projector, and so forth. Is everybody okay? So the data structure is like the room, and then it will have some content. The contents are what we refer to as the types. Okay. Now let's do another one, which will be religion. So these 5 people, we are going to give them religion. So the first person is a traditionalist. The next person is a Christian. The next person is a Muslim. The next person maybe Christian. And the next person, other. So now, this one, you see, I'm not writing values, but rather string or characters. I put some letters together, but I will not be able to store them as a name unless you have given it some, you have assigned it. So I cannot be writing TRAD. I will be searching for it. What is it? And there's nothing called TRAD. Right? So I will be getting an error. So you need to put it in quotation marks, then it becomes a string or a character put together. But remember that we are still using the C and there are commas to put them together. So let's see. So I run this as well. And I come and check in my... And then there's religion, right? What do we see here? CHR. CHR is what? Character. So the data types under this vector is what? A character. And the first one was what? Numeric. Okay. Let's move on. So lastly, we can also get logicals, which is true or false. What question can we answer by true or? So let's say we call it pass, and that means we check whether you pass or not. So true means the person will pass. False, you won't pass. So R also recognizes true or false as what? So you cannot be naming your object true, capital T, or false. It also recognizes T as true and also F as false. So whether you write them fully or you just use the abbreviation F and T, it will still record it. And lastly, maybe T. So, pass. What do you see? What type is it? It's logical. So you see logic. Logic or logical. So we've seen logicals, we've seen character, we've seen numeric. There's also missing values and so forth. So for example, salary. And if you ask this question, not all the people will give you answer. So the first person did not want to answer, so we put NA there. NA means what? Missing. Otherwise, it will distort our vector. The person answered age, religion, true, and then pass. But when it came to salary, he said, no, I'm not going to answer. So salary is also numeric, but it contains what? Some missing what? Values. So these vectors, we can perform some operations on them. So for example, we can get the total salary, right? How do we get that? We can add them. So R recognizes sum. So I can sum the salaries so that I get a total amount for the 5 people. Remember, some of them did not provide what? 2 of them did not what? Provide their salary. So if I highlight only this and I sum, I get NA. Why is it so? Because there were what? Some missing observations. So how do I omit them? Well, it turns out that there's what we call NA.RM, which means it says it is all logical, true or false. Should NA be removed? That's what it is. So I'll click on this and then I say true. If it is true, then it means what? Remove the NAs. In other words, it will just sum only 3. Because 2 of them were not available. 100.41. So that is sum. We can get the product, average, and so forth. Let's look at average. So average may be mean. And that will be salary. Similar to the sum. If we do not remove any, what will happen? We are going to get what? Any. So we can copy this and put over there. Mean also contains any.rm. The average salary is what? 33.74. Is everybody okay with this? So these are all descriptive statistics that we will compute later on. Now, we can also get let's say, we can name the objects. So, for example, there are 5 people. We don't know their names, right? So, we can assign them names, the individual ones. So, which one should we use? Salary or age or whichever one? So, maybe salary. Once I do for one, or we do it for one, we can. So, these are names. So, the first person is Amma. The next person is who? We want only 3 letter words. Yao. One, 2, 3, 4, 5. Okay, so it's fine. Then we do so. Now go and check salary. Let's look for salary. What has changed? You see, now it says what? Named what? Noun. Which means it is named. And so forth. So we can also subscript. So subscripting just means we are what? Retrieving observations. So for example, what is the salary of Ali? So I ask a question, what is the salary of Ali? How are you going to answer this? Well, this one is just a trivial problem, so you can look at it and tell me what it is. But if I give you a data set that is made up of, let's say, 5 million observations, you can't be scrolling through to tell me who. So we can retrieve this with the name or. So we can retrieve this with either the name or what? Or the position. So let's see. Now, so subscripting vectors, we use this square bracket, okay, after it. So to do this, as I said, we can use the position, the name, so using name, we'll call for salary. Then we bring the square bracket. Then the name is called what? Ali. So let's see. Is that the answer? Yes. So that is using the name. Then another way around is what? To use what? The position. So position of Ali. What is position of Ali? What is the position of Ali in the third person? So it means we are going to put 3 in the square bracket. So instead of Ali, we will put what? 3. So that's how you retrieve observations from a vector. The data. Yeah, so that's why there are different ways of using it. If you know the name, you use the name to search for it. But the position, you must know the right position to use. We can also use, we can also retrieve the position and use it, but that's double work. So we can also use which of the names is equal to Ali. Then it will retrieve the position of Ali. Is everybody okay? Now, we can also be selecting according to some criteria. So for example, we want to find all those who are over 27 years or retrieve people within these 5 data sets whose ages are above 27. Now, how do I do this? Well, so retrieving with conditions. So under some condition. So for example, select So how do we do this? Well, we can check age greater than 27. So you can actually use greater than, less than or equal to, and so forth, not equal to, and so forth. So if you check one of the reference tests are in action. So with a reference book, it makes it even simpler. So look, this is what we are doing. So you see, the vector I talked about is a one-dimensional array, right? It's just, so you just have a name and then 1, 2, 3. Ours was 5. After that, we are going to do a matrix. You see the matrix as what? Two-dimensional. We have rows, we have what? Columns. Then data frame is also two-dimensional. But look at the comment. Columns can be different modes. In other words, columns can contain different data types. But for a matrix, they have to contain the same data type. So if they are numeric, you cannot be mixing age and religion. They are different data types, and so forth. There's also an array which is like a cube, sort of. Yeah, but I mean, I hardly even use it. Then you can also have a list. A list is the most complex data set in R because it can contain any of the data structures, including itself. So a list is a vector, which means it's one-dimensional array. But if I choose here, so this part may contain this one. Okay, I move to the next one, it may be containing a data frame. Okay, so you can use a list to organize any data set which has different structures under it. So, but the rest you can't. So this one have to contain the same data structure, so the same data type. So you remember the religion was character, all of them. Age was numeric, all of them. Okay, I cannot be having age 29 and then here I have true, yes, or false, and so forth. It goes with the matrix as well. And we'll demonstrate if we have a matrix and we add a character vector, you realize that everything will change to character. So, but data frames are quite good because it helps us to maintain a rectangular nature as well as all having to contain on different data types. So if you remember, we did look at inferred, right? Remember, it contained different data types. And it was called what? A data frame. And so forth. But state.x77 contained only numeric. And it was classified as what? A matrix. Because it's also this. So this and that, they are the same. The only difference is that this one can contain all different data types. And then lastly, we can put all of them under what? A list, so to speak. Okay. I wanted to show you some, there's a table. So have you downloaded this book? Not yet. You need it. Vector operations. I have forgotten the page number, but let me search for it and see. Oh. Oh, it came. Okay, so let me. Matrix algebra. There's a table. Oh. Okay, yeah, this is. So these are the logical operators we can have on a vector. Okay, so less than, we use that. Less than or equal to, greater than or equal to, not equal to. This is not x, x or y, x and y is or true. Test whether it's true. So what we are using now is what? Greater than. Is that okay? And these will all evaluate to give us either true or false. That's why we call them logical operators. Okay. So let's go back. So if I run this, you see age. Yeah, so is 20 greater than 27? No. So you get what? False. Is 27 greater than 27? No. 25 greater than 27? No. 34? So true. 29? True. And so forth. Okay. So I can also retrieve the age of those who are over 27. How do I do it? Well, it means that I need to call age and put that condition in there. Because it evaluates to true or false, it will retrieve those with true and omit those with false. So if I do this, we only record those that are over 27. Is everybody okay with it? Shall we move on? Okay. So when you get this, well, please try your hands on some of these. Okay. All right. So from what we have done now, can you look at this one? Can you tell me what is happening here? Let's see. What do you think? This one, the one that is highlighted. What is not equal to? Where we have two equal signs, what does it mean? Exactly equal to. Okay. So those that are with age equal to 99 will give us what? It will give us what? What will be the answer? That will be true. If you are not equal to 99 years, what will happen? False. Okay, so once you see this square bracket, then it means we are now retrieving, right? Okay. So we will retrieve only those with ages greater than, ages equal to what? 99. Is everybody okay with that? Yeah, so that's it. Then remember, this is what? Assignment. So what is happening here is that all those, leadership is the data. Okay, so in leadership data, all those with age equal to 99, let's give them NAs. Is everybody okay with it? Yeah. Sometimes you give, let's say, you ask people to go to the field and collect data. Some of them will, instead of 20 years, will press it maybe the 0 2 times, then it becomes 200 years. Then you come and then you're analyzing it. When you do a box plot, you realize that 200 is somewhere up there. And you want to take that one out. You may take it out or replace it. Because let's say the person has answered 30 questions. Because the age is wrong, are you going to throw all the other answers away? No. So you replace that age with what? Any. Right? So we can also say all those with ages greater than 100, replace it with what? Any. Because we know that nobody in this exercise will be above 100 years. So that's what you can use some of these simple operations for. Please, is everybody okay? Yes. All right, okay. So let's move on. So that's a vector and how to name it, how to retrieve observation from it. There are so many things you can do. For example, we can also get the length. Length is what? Is a sample size. So how many observations? 5. Do you remember? We had only 5. Okay. So sample size. So now that's a vector. I can now move on to B, which is matrices. Should I add data frames? Yeah, matrices and data frames. So a matrix is a 2-dimensional array made up of what? It's a 2-dimensional made up of the same word, data type. Whereas data frame is also a 2-dimensional array but it can contain what? Different data types. So whatever we are going to do here applies to both words. For example, when we are subscripting, it's the same. Okay. It's just a creation that is different. Okay. Yes.
What's the meaning of array?
It's just what you have over there. If you, where was the like the box, right? The boxes that we showed. Which page was that? I think it's the data structures. Let me see. Not getting started. I can't find it, but I showed it not long ago. Okay, so let's see how we create a matrix. So creating matrices. So matrices can be created using the following functions. So A, we can have a matrix. So the key matrix. B, we can use a C bind. And then we can use what? R bind. So any of these will create a matrix. Any of these will create a matrix. Okay, so we had salary and age created, and those were the numeric ones, right? Okay, so I can create a matrix called mat1, and that is C bind. So I'll use C bind and R bind, then you see the difference. And then I call age and then salary. So if it is C bind, it's column bind. So it will take each variable and attach it column wise. So this one, what we expect to get to be what? A rectangular array made up of what? 2 columns. And there it is. Is everybody okay? So that's how I see it. If I use row, we will now get to what? 2 rows. But that's not how we save data. The columns should be variables and the rows are individuals. So it shouldn't be mat2 R bind. So this is not a proper way to represent a data. Is everybody okay with that? We don't store a data set with the names as columns and the variables as rows. It's just like Excel. In Excel, what do? The columns are your headers. Then each individual, you enter the data what? Row-wise. So that's it. So the first one is the correct one to use for math. So Amma is 20 years and Amma didn't want us to know her salary. Abigail or Abi is 27 and earns 19.45, maybe 1,000. Ali, like that and so forth. So we don't do it the other way around, like this. So now we can check that, let's say math 3. We want to add religion to it. Please remember what we talked about, that a matrix contains only one data type. Is that okay? Religion is character, isn't it? So let's see what will happen to math 3. Now, to be able to display, remember that you see here, I have to assign math, and then for me to call it, I call the name, and then it displays the content. Now, we can do this at a go. That means assign it and also display it on the console at the same time. To do so, we put all the commands in what? In parentheses. All right, so I'm going to do so for math 3. Oh, I should be doing it here. So for math 3, I highlight it and I put it here. So let me make a comment that this is assign and display at the same time. Assign and display content. So this will be done like this. There we go. Oh, I wanted to use cbind rather. What can you see? Yes, okay. Because we added religion, and religion is character, you see all the ages and salaries have been turned into what? Character. R provides quotation marks for all of them, but that's not what we want, right? We want the data to stand on its own, so that we can call age and find the average age. We can find the maximum salary and lowest salary and so forth. Okay. So to be able to let the variables maintain its data type, what we need to do to use is what? A data frame. Remember, the data frame can contain what? Different data types. Okay. So 2 is data frames. Data frames. So to construct a data frame, we just use data.frame. So let me call it df math, and that will be data.frame. So that we can just copy this and paste in there. And we can also put it in what? Parentheses, so that it is assigned. There we go. What is the difference between this and the previous one? There's no quotation marks. Yeah. So that's it. And this one, the variables what? Maintains the original data structures. So for example, I can select the maximum age. I can't do so, so I'm going to do so for the math 3. So max, math 3, It still gives you 34, but it's what? It's a character. Yeah. Let me sum. It tells me what? Type character of argument. So I cannot be adding characters, even though I know that age is not a character. But in the this one, the data frame, I can get a sum and so forth. If it's the data frame, I can get a sum. So age, there we go, 135. So, okay. So that's the distinction between what data frame and what a matrix. Shall we continue? So now, operations or subscripting, this one, let me do subscripting. So how are we going to subscript? Subscripting with matrices and data frames. So here, because it's two-dimensional, we need the square brackets will be one, but we need two, the position on the row, the position on what? The column. So we need two. So for example, let's look at the DF math, this one. So how can you tell me the salary of Abigail? How can we retrieve the salary of Abigail? Yes. Yes. Which row is Abigail? Row 2, column what? 2. What if we want the age and salary? Column 1 and 2, good. So how do we do this? Well, so how do we do this? We'll first call DF math, and then so this one too, we can use the positions, we can also use all the names. Okay. But in this case, the square bracket, we need a comma. The first space before the comma is for rows, and then after the comma is for columns. So remember, you said that we need what? Position 2, right? Row 2. But the columns, we need what? 1 and 2, isn't it? So 1 and 2, we'll use 1:2. Okay. So 1:2 means 1 and 2, right? If we want 1, 2, 3, that will be that. And there it is. Is everybody okay with this? Now, if we leave any of them blank, it means select all. So for example, if I needed to get the age, salary, and religion, of Abigail, I can also take out this. I can do it 1:3 because there are 3 columns, or I can also equally leave it empty like this and run it. If I run this, I get all the. It means that if you want the columns to, what do? If you just want column, it has to be what? Yeah, after the quotation mark. So let me do this and then I make comments around it. So this one, what did it? Okay, so that answers the question. Okay, so that's it. So here, retrieve the data for Abigail. In that case, we just need one. So it is either that one or this. Any of them will give you the same thing. If I run both, we'll get the same result. Now, 2, we can also use the name. Remember, we were able to use the name and what? Positions. So, the row name is called what? Abby, right? Yeah, so let's see. There we go. If you want the columns too, you can do so as well. Yeah. But that must be after the comma. Is that okay? All right. So that's how we will retrieve observations from these data. Did I send you the data for the fisheries? Not yet. I have not sent you any data on your WhatsApp. The air quality is okay. We will now use real data sets, so that's why I'm asking. Okay. Please, is everybody okay with this? Because I want us to go and read that data, and then we do some practical. I think we can take a break, and then after that, we'll do so. So everybody should download that data into the folder you created, and then when we come back, we'll read it. Those are real data, and then we do some of these data wranglings that we are looking at. Okay. Let's take some break. It's 14:08, so by 14, latest 20, we should get back. Let's take some break, stretch.
Okay. They should, if it was having this on the
This is computational statistics.
they had the first arrow.
This what it has.
But if you are saving, it's supposed to show you the one.
We did the content
You don't open it, but
as
you
we
are
said.
just.
So what should I do? So what should I do now?
Try saving it in that folder.
When I need to, I'll just save it. What can I save something? That's all. Which one? What's it called? The one of what?
I say we should copy it.
Lucky, but if you don't need to, can you always say?
You can't save this one. I'm not saving anything, so you put on where you want to save it. You will choose a directory where you want to keep it there and save. And then save. Then save, do save. When you type in,
Of what? Today's week? 17. Now cancel
The one you just saved. Yeah, open the Excel sheet to see. Or you
Yeah, I want to find the use of this weather is what I need to
I want to check my laptop. But I don't know how it's going to get there.
please, Dad, sorry me. Sorry me.
not coming today.
I'm trying to open it. See, you see, can see Excel.
It's not opening.
Hey. So, hey. Gotcha. That's a lot.
I didn't say it, and I saw it, but I forgot to tell you.
No, you're not doing this. I just said, I'm like, hey, if you do something, you play an honest, let's go over. Big trouble. So it's at today's one as well. But Naki was talking about some directory. And it's from the directory that I don't know, but now it's actually about, can you see something? Let me go to the directory. Let's say who was the directory thing is
Just save it.
and save it in this file.
Yes.
So the directory thing you're talking about
It's going to keep all of the files of just one. So when you pick the data set in that folder, I will only run your data set in the same folder. So let's say you have a new file outside the directory, and then the data that you have is inside the directory, but not in the file. I'm not going to open it. I'm not going to give the data set to you.
this one, let's say
So it has to all be that's the data so that we can put it in that directory. So that will just make it.
is it there? Is it there? And is it there? Is it there?
So just save the file in that. That's folder.
sorry, last week that's it's supposed to reflect here.
When you put it into the folder, it's supposed to
Yeah,
be
it's supposed to reflect here. I think your transcribe. Go to file. Scroll down. But last week it reflected here. I don't know why today is not reflecting. Daniel Carey, that's why it's not reflected. She's doing something.
something else.
She's doing something. We're trying to figure out something.
I want to help. You want to do you want to do laptop. You want a new
You want a new laptop?
so it's not reflecting. So but it's not reflecting. Isn't it reflecting?
Who on the laptop? Who on the
Me.
Which is that?
Leo.
Why is it in the
You didn't say anything. I want to. You didn't say what you're going to do. I'm not paying attention.
You don't want it. That is your plan. This one is. So why not?
Hey, through you. Aren't you losing on time? Right there.
Is there any question? Any question? If you have any question or you get that, please, you have to alert me so that I come around or one of my TAs is around to help. Okay, so now let's see. Let's read in the data. So we are left with one data structure. So I think maybe let's do the last data structure. Then we'll go and get that practical data set and start. We'll do some data wranglings and that should be it with data. So the next, or let me, remember we talked about the length, right? The length to give out the sample size. In the case of the rectangular one, you can also use the dimension, so dim. So dim of, let's say, DF match, remember, will give us the rows and columns. So it means 5 rows and what? 3 columns. Okay. All right. Of course, we know about the structure. The structure will just tell us which data structure it is. And of course, we can also get our data types within the structure. So that's what we've done. So dim to get the dimensions of the data. And this is for rectangular data sets. Okay. So let's do the C is list. So what are lists? So list is also a one-dimensional data. One-dimensional data. But each object can contain any data structure. Please do you get this? It can contain any data structure, including a list. Is that okay? So it's a data structure that can contain its own structure as well. It's one-dimensional. Each object So I can have a vector with as a first object, a matrix as a second object, a vector as a third object, and so forth. Is that okay? So let's create one. To create a list, we use list. So the list function creates a list. So what is it? So let's say our first list is called my list. It means we have list. Then we can put in age. We can put in, do you remember our matrix? Our matrix was called mat. We had mat 1, right? So mat 1. Then we had a data frame. So data frame, that was all df mat. What else? I can put in the letters of the alphabet. So R recognizes letters. So this will be either small or capital letters. So that's a vector. We can put in another thing. What data were we even looking at? Fet, right? Infet. Good. Okay, that was a data frame, right? So data frame 2 is infet. Good. Okay. So you see, the first one is a vector. The next one is a matrix. We have a data frame, we have a vector, we now have a data frame, and so forth. So the list is so complex. I forgot to add it, that including a list, that it is the most complex data structure. In R. Is that okay? Yeah. So if you look at this, we run it. My list, so it's a list of 5. Of course, it's age 1, 2, 3, 4, 5. You see, age, I did not assign anything to it because age is already there as well, a vector. So if you look through it, it tells you age is not. If I want, I can just to be consistent, age is equal to age, right? Then I run it. So here you see now age is there, numeric. Matrix also numeric. It has these attributes. Data frame, some are numeric, others are not. Letters, character. This is also a data frame. I can add on and on and on and on and on. But remember that here you have some rectangular, some one-dimensional. I can place this list within another list as well. So let's say if I work in a company that, let's say at the headquarters, we can have regional branches. Not all, the regions are different districts. Some have more districts than the other, and so you can use a list to organize your data, where you have the main list, then it goes to 16 regions. Then under each region, you can also have a list containing districts. And even districts, you can now have all towns and cities and villages and so forth, all within it. So that's how powerful a list can be. And we can iterate within this, like a tree. So you start from the top, you go down, 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 until you get to the last bit. Okay. Now, so that's a list. The question is, how do you can also display the content of this list by highlighting it and running. So you see, this is the first one. It can't display all of it. So it takes some off. So you see the letters. This was the infet data. Then letters. Then you remember our data frame we created. This is also the matrix we created, and then age and so forth. So that's how the arrangement is. Okay. Now the question is, how do you retrieve? So how do you subscribe to a list? Subscripting. Remember, this is also one-dimensional. For one dimension, we use just what? We just need a position or what? The name. If you remember, the way we retrieved objects from a vector is the same, because list is also what? It's one dimension. Subscripting with list. Okay. So 3 ways of doing this. We can use this or that, right? And then we can use a name. So let's see. So I can use a position. So my list, let's assume I want to retrieve the letters. So what do? I'll count. It means I need to know the position. So 1, 2, 3, 4 is the 4th one. So C. Okay, so this one, we'll retrieve it as a list. Okay, so what I can do is that I can, let's say I name it let. So let is this. Now if I check the structure, this should be a list. You see, it's what? A list of 1. Okay. Now I'm going to use the double one. That's also the same, right? It also gives you the same, but that will just retrieve the actual data set within it, or the data structure stored within that list. So remember, this data structure is a vector. Letters is just A, B, C, D up to, so it's just one dimensional. So it's actually not a list. But if you are retrieving it, just a position, it will come as the list itself. So if we want to get the actual one, what we do is that we use the double one, and let's say let 1. Okay, so if I do this, I should have done it this way. Okay, so you see, now it's all like that, but let me go and check the structure. It will be a vector and a character vector as well. So you see character, 1, 2, 3, and so forth. This may not be too, but it becomes necessary when you are doing, like you pass it through a function. These data structures are very important because that's the basis of statistics. You have to store data. So if you don't know how a data is stored, then there's a problem. And sometimes we are going to call a function to do some work. The function may need a certain data type. If your data doesn't conform to it, you won't be able to do it. And those are things we will do later on. So basically, that's it with list. We can also, because it's one dimension, we can also get the sample size or number of objects by using what? Just the length. So the length will give you how many objects do you have in the list. So length of, let's say, my list, in this case will be what? 5, right? 5. So forth. So basically that's it with data structures. Now, with this, we now can talk about data types. We've seen all the data types. Let me just reiterate them. So data types. First, we've seen numeric, right? The numeric will also, other ones will be integer. In some cases, you have long. There's also long double. These ones, it depends on how you store data. The data set is so wide, or it has points, and some are whole numbers, so it will be able. So we've seen numeric. We've seen what again? Character, right? Is everybody okay with this? We've seen character. What else have we seen? We've seen logicals. These are the true or false, right? What else have we seen? missing values. Those are the what? Any's. We can also talk about E, factor. Now, a factor is just the, remember our data, I did not bring the marker. Okay, so. The last week I drew data types, quantitative, qualitative, right? And then you've done scales of measurement, nominal, ordinal, and so forth. When we have a categorical data, like the one we had in the infant, the age will be ordinal, because you realize we start from 0 to 5. 1 is 6 to 11, and so forth, right? So it's like if you are in 2, it means let's say if it is age, your age is more than the one in 0. That's it. So there's some sort of order attached to it. R allows us to also store data types like that, right? So if you look at the structure of the infant, just look at it. It will tell you that some are factors. Education, you say factor with what? 3 levels. 0 to 5, and so forth. Okay, so a factor is actually categorical data. Okay. However, we can distinguish it as either nominal or ordinal. Is that okay? So, for example, let's assume that we give, let's say, status of some, we observe these 5 people. Let's assume they have maybe something that we can rank it. So let's use a Likert scale. So this person disagrees. The next person agree. Agree. The next person says, I strongly agree. You've seen something like that? Yes. Yeah, so that's a Likert scale. Okay. Next person says, strongly disagree. Do we have 5? 1, 2, 3, 4. Okay, 5. Okay, so this one. So yes, but okay, so we have that, but it's just like the answers we got. Is everybody okay? So there are 5. 2 people can say we agree, and so forth. Yeah, so that's it. Okay. Okay. So let's see this. Okay. Now, if I check this, they are characters, right? They are characters, which means we are just written some names and then we put them in quotation mark. Okay. But remember that I have disagree 2 times, right? Okay. So I can convert this to a factor, which means I will write this without necessarily bringing in the quotation mark, because I will just put it as the nominal scale. So how do I construct a factor? Simple, just factor. Then I just put status in there. Now, then let me look at status. So you see what is happening? You see now it is written disagree, agree, strongly disagree, strongly disagree, disagree. But how many levels do we have? Only 4. The unique ones are what? 4. Is everybody okay with it? I can go back and, for example, take, let's say I take this one off. How many do I have now? How many unique answers do I have? 3. Okay, so I can rerun this and then display status. You see 3 levels, agree. So it does arrange it, agree, then we have disagree and strongly disagree. Is everybody okay? Okay. But sometimes, if this is a lighter scale, so we have to get some strength as we move along. Usually, you move from strongly disagree to strongly what? Agree. Okay. Maybe strongly disagree, you give it 1, then it means disagree will be 2, then 3 will be neutral, then 4 will be agree, and then 5 is what? Strongly disagree. So strongly agree, and so forth. Now, how does this using alphabetical order? So you see, agree, the levels are agree, strongly disagree, but they are not arranged in any way. What do I mean by that? There is no order attached to this. So if I want order, I need to tell R how then it changes from nominal to what? Ordinal data set. Okay. So this is nominal. This is nominal data or nominal scale. Okay. If I want ordinal scale, I'll have to, so let me just do question mark factor so that you see what you see, because I have been doing this over and over and over again. If I take a function, I know what is in there. Okay, but you may not be able to do that, offhand. So usually what you do is that just get the help files and then you copy and then put in what is necessary, right? So for example, factor, it says X. X is a character. That's what we did. Status at first was a character. So we provided factor with character. We did not put any levels, but it automatically generated the levels without repetition. Okay. Then labels. You can also label it as well and so forth. So all I want is also levels, and then there is ordered. This is very important. Ordered. If ordered is true, then it means you are the ordinal scale. But by default, it is not ordered. Right? So just take it in alphabetical order. So this is what we're going to use. And usually when you come here, you have what? Examples to work with. And so when you have anything like this, you can just copy, paste, and see how this function is used, and then some examples of it anyway. So on the ordinal scale, I'm going to add ordered is equal to, so to distinguish it, I will put O here. That is ordered status. Then I will call ordered. So what I'm saying is that you can type or just come here. If you go, yes, here, then you pick ordered. So you can copy and paste. Or when you start typing, you slow down, it will come, then you select. Okay, so that you don't make mistakes. So ordered is true. So T is true. Then the levels. How do I want the levels ordered? Well, I need to come here and tell R how I want it to be ordered. So for example, I want strongly disagree to be the least. Is that okay? Remember, I just did agree and so forth to strongly disagree. But I want to make sure that I start from what? Strongly disagree to agree. Okay, so I can then go here and just copy so that we don't waste time in doing this. So strongly disagree will be first. Then the next one will be what? Disagree. You see, here I can put in all the Likert scales. But some of them I will not have it anyway, because the 5 people, you know, when you give them a questionnaire, all the 5 will be there. But people will just choose what is applicable to them. So if you are entering this data, all your 5 will be there, right, and so forth. Yeah, but this is just a small example. We don't want to waste our time. And then the last one is what? Agree. So we just use a 5. But in practice, we should have what? All the 5. Such that. So let's see. So I do this. There it is. I run it. Now let me call for this. You see? So you see the levels. Strongly agree is what? Less than. There it is. Strongly agree is less than disagree, which is less than what? Agree. So in this case, it means that my numbering, strongly disagree will be 1. Disagree will be 2. Then you come to neutral and so forth. That's a sort of thing. And that's what we mean by a factor. So this is no more. So we are in groups. They have grouped, but there's an order attached to it. If I want to do this for it to mimic the 5 Likert scale, I need to bring in, here will be what? Neutral or what else? Indifference, if you want to. And then the last one will be what? Strongly agree. So we can do that if we want to. So I need to take this out. Okay. And then I do this. So this is actually the full meaning if you want to get a Likert scale. Okay, so 5 levels Likert scale. Strongly disagree, then disagree, neutral, agree, and what? Strongly agree. But in our the 5 people, nobody chose neutral. Is that okay? So that's the sort of thing we will be doing. And that's what you see in the inferred data. So inferred, I forgot to add that in the list and also the data frame, you can select the variables with the $sign. Okay, so inferred, remember, if you do, the variables can be selected, that's the columns can be selected for in a data frame with the $. In a list too, you can select the objects with the $sign when you are subscripting. Education was a factor. So let's see. You see, it will list all the 248 values, okay, and then provide us with what? The levels. So let's see. So you see the levels are only 3, but there are how many? 248 observations. So the levels are the unique options, because there will be repetitions. If I ask all of you whether you agree or strongly disagree with the government handling of Galamsey, the NDC people will say we strongly agree. MPP will say strongly disagree. And then the neutral people will just, yes, and so forth. So that's it. So you have maybe nobody over here will take what? Agree. And so forth. So that's the sort of thing you see in a data set. And that is a factor. Okay. So a factor is also a data type. And then lastly, we have dates. So F, you have dates. So R also recognizes dates, time, and so forth. So for example, we can type sys.time. Sys.time, it will tell us what time it is. No, not this one. Sys.date. I want date rather. So date it should be just sys.date. This one will check whether the time to compute an expression. But date will give me date and then I can have sys.time. So today is 17th, right? Sys.time. Will give me the time. So it gives date and time at the same time. And my distance is set to GMT. So R recognizes dates, but programming languages is good if you represent dates in Julian. So the Julian dates, those are numbers. So you can add, you can subtract, you can do everything you want to do with dates in Julian format. So there's a data set called ASTA607. It's in mass package. So for us to be able to get it, what do we do? If you want to get access to a package, what do? You take it. Okay, so either library or take it. So mass, let's take mass. Then when you take, before then, don't take it because I have to explain help. So don't take it. If you take it, just detach it. Now, let's all do question mark AS2. I think it's AS2, like that. Question mark AS2 and do it. What do you see? No documentation for ACE in specified packages and libraries. So the first question mark, remember I said searches through the packages in the environment. So it tells you that I did not find any documentation on this. Okay, but that gives you a clue that use what? Double. Now this one will search through all the packages you've installed in RStudio. So let's see. And it takes a bit of time. Because I have several packages, is to search through all of it to see which packages has what? AS2 in there. So it will take a bit of time, but we'll get our results. So anywhere it sees AS, closer words, it will pop it out. But I want AS2. So you see it's in what? Mass. Because I've been using this, I have it often. So that's what. But if you don't know, it's always good to go with the double sign. And it actually searches through matching words. So now I know it's in mass. Good. I can click on it and get help on it, or I can also come here, take mass, and then I can now run just a simple search, and then it tells you this. This is the Australian AIDS survivor data. It's data on patients diagnosed with AIDS in Australia before what? 1st July 1 hour. So when I ask you to describe a data set, this is what I want you to do. Is that okay? So you have to tell me the help and so forth. All right. Now, so the last bit of the class, I'll leave you with an assignment. You do it and upload it on Sakai. Is that okay? Yes. So you tell me you need like 20 minutes to do it. So 4 o'clock, right? No, when I leave. So, yes, today. It's a class exercise. So I'll leave you like 30 minutes, then I give it to you, then you do it. Is that okay? I'll post it on your WhatsApp. Okay, it's not anything. We've even done one now, which is help. Okay, so help, you use what? Question mark. And the double one will what? Set through all packages you've installed. So if you are not sure where the data is, what do you do, or the function is, you use the double question mark. Is everybody okay with it? Okay, good. Now I talked about dates, right? So let's look at this data set. It's a data frame. So we know that this is what? Rectangular, right? Good. And it means it can contain what? Different data types. Good. Okay, so state is what? The group state of origin. What data type will this one be? State. It will be categorical. Well, but what data type? Would this be ordinal? State of origin. It's just like the region you come from. Nominal. Good. Okay. So if it is a factor, it will be without order. Good. Okay. Sex of a patient. Died. You see, this is what I was talking about. Julian date of diagnosis. Okay. So let's look at the head of this data. So head means just give us some few. The first few observations, usually 6. And of course, if we have head, we'll have what? Tail as well. So tail will also give you what? The last 6 observations of the data. So head, tail, let me rerun it again. So you see the head, first 6 observations. So the first person comes from New South Wales. The person was a female. The diagnosis date is 10905. So this is date, but it is numeric. So you're able to, do so many things about it. So if I have the date of diagnosis and the date of death, how can I get the survivor? I usually give this as an assignment. So in exam, you say, you did not teach us survivor. What? You have the date a patient was diagnosed and the death date. What is a survivor? You find a difference, yes. Yeah. So if I give you this, I'll say find a survivor, and then you say we did not teach you survivor. Okay, so this one, the status, D is death and A is alive. So this is, who is doing, have you done survivor analysis yet? Not yet. Okay, so there is a course like that, survivor model. So this is, you can follow patients. Some will die along the way. Some will even leave the jurisdiction and you can't have access to them. And some will still be remaining when your study ends. So if we hear of censoring, that's it, the statistical term censoring. So if a patient is still alive, we want to see your survivor and you are still alive and the study ends because you can't follow them. Let's say if you are doing your project, you have barely 6 months or 3 months to do this. You cannot go and follow patients for 10 years. By the time you come back, you have to pay school fees like 10 times. Do you get it? So you can you go to Legon Hospital, they give you patients, you follow them for 3 months. Those maybe terminally ill people, those who have died, they are survivor. Those who have not, it means that they will die in the future because nobody will live to the end of the world. So they will die in the future. So statistics helps us, even though we don't have data on them, to be able to project ahead and see when they will. And it's not only death. Okay. Just a while ago, I was having a discussion with my PhD student. What we are doing, this is in the same context. we are building model to predict when an employee will exit a company. Okay, so you will follow them for 2 years. Some exited, some are still there. So those that are there, you still want the model to be able to predict when they will leave. That's a survival model. So those people are what? Censoring. Okay, so when you hear of censoring, don't say we have not taught you. At the university, nobody teaches. We lecture. Okay. Okay, so in other words, you learn along the way. So whenever we have terms, I'll begin to explain, and then you note it down. When you go out and you say you have, is it big data or applied statistics? This is applied statistics. They will call you. You cannot say you don't know. Okay, and the other trick is, that's why we are teaching you how to do research. So if somebody comes with a question, oh, this one, you have to find something to do. That is to give you the chance to go and research. Okay? So if the person, you listen, and you go, oh, okay, this one, but for now I'm having to do something now, urgent. So you let me do it, and then later on. Otherwise, they will say you don't know anything. But you can't have, I don't have every statistics in my head. Even, yeah, so we are all students of statistics. The fact that you're a professor doesn't mean you know everything. Everybody has, statistics is so broad. We just look at packages, and we started from accounting through to zoology. Even zoology, you get something to do. So what they are doing, they may be using statistics, that is somehow basic, but you may not know. So always create that chance. Otherwise, you go to say, oh, you say he has master's degree in statistics, and this one he doesn't know. Do you get it? It happens, especially at the job. So find something to do. As soon as the person leaves, you have Google to your advantage. Okay? Search, and with what you know about this and so what we will teach you, you know the methods, you'll be able to solve it. So that's how. Otherwise, we are all, our integrity is at stake as well. They will say the person came to University of Ghana, you say he has applied and he can't do this. We want you to do it, and then you become good ambassadors of our cause. Okay, so that's a trait. And the other, you in your inferential study, people will come to you, they are doing something, they say sample size. You don't tell me I'm going to do what is the sample size, and I tell you that you should use it. You have to ask questions. Ask questions. What have they done before? Let the person provide you with all those, and then you sit down and then calculate it. So that's a simple, but it's not an easy thing, because it comes with implications for money, time, and so forth. In your project, if you want to go out to collect data, how many people do you want to go and interview? You cannot go and interview 1,000 people unless you have that much money, right? Okay, so you find a way out, but usually it will be a compromise between cost, time, and so forth. Okay, so those are those statistical issues you face. Okay, so death, survivor definitely will be this minus what? That one. So if the person have not died, so this one, dead, we know their survivor time, exactly. But these people, they are all alive, isn't it? So you cannot subtract death from that one and say that's a survivor. No, a survivor is what? Censored. Please, are you following? Yeah. There's a course in this. There's a whole area in statistics, survivor analysis. Okay, it's important that you know bits and pieces of every aspect. Okay, so that when you face a problem with what we are giving you, the basis, you will be able to solve this. But this is typical survivor analysis data. We will come back to it later on when we are doing graphs. Okay. So that's it, and the main reason is about the Julian date. Okay. It makes it easier to even type, rather than, I can also type date with 12 March 2026. 12, but if you have to type this data in Excel, you are now going to type 12 dash days. No, you waste your time. So if it's Julian, you just type numbers, and then you are off to go. So that's one way of representing time in there. Okay. Any question? So that's it with data structures. We started with a vector. We said it's what? One-dimensional array. It can only contain one data type. So if it is true or false, it must be true or false. If it is numeric, it must be numeric. We can retrieve observations from this one-dimensional array using the square bracket and either providing it with name or what? The position. That's it. Then from there, we talked about the rectangular ones, which will be matrix and data frames. These have rows and what? Columns. The columns are the variables, the rows are the individual measurements. Okay. So there too, we can retrieve observation by specifying the row and column. If we leave some to be empty, it means retrieve all the rows or all the columns. Okay. We can get the dimensions of it and so forth. So the rectangular one, the one that can contain different data types are all the data frames. Okay. And the one matrix will contain what? Only one data type. Then after that, we talk about list. We say list is one-dimensional. It's the most complex data structure because each object in there can be a data structure on its own. And it can be a data structure in which you have other structures in there, including a list. So that's it. And that we can also retrieve observation using the square bracket. If we want to get the actual data structure stored within that part, we have to use a double one. Okay. You can also put the name of that in quotation mark, just like we did for the vectors, and you can retrieve it. Under a data structure are data types. So the data types, you can get numeric, we can get character, we can get logicals, we can get missing data, we can get dates, we can get factors, and so forth. That's what we've done now. Okay. So now, what we are going to do is that we've seen data types, data set, real data set already in R. But I've given you data sets on air quality and what? Inch bio, right? The air quality is about air quality in, I think, New York. The inch bio is some fisheries data. We want to be able to analyze this data. It's not already in R. So it means we have to find a way to what? Read it into R. Did you read it the last time? Not yet. Okay, so now let's read this one. Yes.
So let's have you read the Julian dates.
You can convert it into the particular date. I think it starts from a particular time. So 0 means something. So you can now check to see which date. But if you are working in programming, it's easier to work with the Julian. You can convert it from Gregorian to Julian. Yeah. So now, importing data. We can actually, so importing and exporting data. Okay, so it means you importing data into, and okay, let's say importing data into R. So we can import data from, so usually it is easy to enter data sets. There are data sets that you can enter yourself, and there are some that, let's say, you go to an organization and then they give you the data. Usually it will be in Excel, right? But sometimes you have data sets online, you cannot sit and be typing 200,000 lines of data. Okay, so you have to find a way to read it straight away into R, and that's what we are going to do. Okay. So first of all, did you create a folder the last time? Okay, good. So store that, if it is a data in Excel, you can store it in there. Okay. So I think I gave you this data set, right? Air quality and then inch bio. Now, open it and stretch it over here. Remember, the air quality is Microsoft Excel, comma separated document, right? Good, okay. So, and this one too is the same. what I want us to do, they are different. We want to store it at SLXX. That's Excel workbook. This is not Excel workbook. Okay, so we can store it like that. We can also store it as test. In other words, I can just copy and then paste it in Notepad and save it. They have different extensions. So let's do this. So click on air quality. Let's start with air quality. Good. Okay, so the air quality data is like this. Let's delete the first one, which is just numbers. It's not needed. Yeah, so delete the first one. Okay. Then, once you are done, you see there are NAs in there, which means they are missing values. So this one, the ozone was not given, solar was not given, but you have data on wind and so forth. So you don't throw it away. Okay, so that's the missing data. Okay. So now let's go to File. If you finish deleting a file, then Save As. Then you see here is comma CSV. We want it to be Excel workbook. So save it. It can be saved the same name because they have different extensions. So click on Save. Okay. File, Save As. Then File, Save As. And then the file type. So if you come here, you see I have Air Quality 2. They are different extensions. This one is Microsoft Excel worksheet. Is everybody okay? Not yet. Okay, so open it, go to File, Save As. Because I have saved it already, it says save a copy, but you will see Save As. So click on Save As. Then it opens this. So here, click under it and select Excel workbook. Excel workbook. Then just save. Because it will have different extensions, it will be this. We can have the same name. So we'll have yes, so click down. Yes. Yes. And then Excel. That's the first one. Excel workbook. Okay, good. So you should have two instances of air quality. One is Excel workbook, the other is comma separated. What are the sizes? Check the sizes. What are the sizes of the air quality, the CLD and then the Excel?
4 and 15.
Okay, so you see that one is almost 3 times the other. The workbook stores data with higher, because you have all the functionalities of Excel. So when you have a larger data set, this one is not that, but if you go to, let's say, those are the, let's say, Wkend or genomic something, they deal with a whole lot, those are the sequences. Maybe a data set may be 30 gigabytes. So if you can store it in CSV and it will be 1/3 of that, that's like 10. Yeah, so that's why sometimes we save it in CSV. So do we all have the 2 copies? Yes. Can we do so for the inch value as well? Double click on the inch value and save it as Excel workbook. Those that are not on Sakai, you have to remind me, then I add you. Okay. Please, are you done? So each value to you have 2. One CSV, the other one. Excel. Good. Okay. Are you done? Then the next one, go to Notepad. Notepad. So search the Notepad and select it. Notepad. Then you go to the air quality. Just copy all of them and paste it in the Notepad. Air quality, any of them, because it's the same data. Just select all, Control A. And paste it in there. So you see that you have test. If you save it the same day, air quality. Save. So you have 3 air quality data and also in bio data. One is Excel, the other is
Which one are you using? The Excel one.
CN, and then you have notes. Are you done?
Is it the Excel one?
Yeah, yeah.
Are you done? No, you have to go this one. You can. So do you have the data? You put it. Are you not on the WhatsApp?
See, this option I did.
Are you connected to the internet? Yeah, you should be able to connect to it. Right. Because I'm able to connect to that. So,
Connect.
the inside your ID number and the 5 digit number.
This one.
These are very important, so I want everybody to be able to do it. And it's not difficult at all. The password is your 5 digits. Oh, no. You see, you have an ID and then the 5 digits in. Yes, that's your password. Did it work? So send it, you can send it to your mail and then you can download it. Just type air quality. Start typing air quality. Take your time. Yes, let's select. Okay. Now run this. Okay, so you see that this is very right. So now select it. You are selecting all the issues. No, is that the first one? So you go down to the last bit and select it from the last one. No, it's easier when you select it from down to up. Or you give me your laptop. Let me do it. The folder you have. Give the folder.
It's a system, so I'm not sure if I will do it. That's possible. Is that side way?
Where did you see the data we think you have it already. You have it in there. Okay. So let me see this one. And then we have please, have you been able to do the notepad? So just open notepad. Okay, and then just paste, copy and paste in there. So now you can save the notepad. Save it, save their quality in that. Who else? Who is having problem? Yeah, you can pay for it too. But we'll use the air quality and then when it goes, who is having problems? You're gonna. The note, just type notepad in your search. Note. You have notepad. Oh, the notepad class. Yes, but that thing was on the web. Is there? I think you don't have. Oh, but that is always basic. If you don't have. To learn, but it's okay. It's once we have the Excel, I'll show you the other way around. It wants you to log in. Okay, so now let's see. How do we read the data into R? So let's all look over here. Now you will see import over here. So import, if you click on import, you will see test. So the test is for the notepad one you did now. If you want to read a test, it can be through the base package or through reader. Usually this one is it's system library, so it's okay to use it. But you can also read from Excel. That's the Excel X we did. You can read from SPSS Sans, and there's foreign package to help you read from even more other programming languages. So let's use the Excel. So click on it from Excel. This is everybody there. So go to import in your environment, click on it, and then from Excel. Are we there? Okay, good. Then it comes to file or URL. So click on browse. Now, if you have set your working directory to your folder, it should open your folder for you. It's not open. Okay, then go back. Preparing to import. So it needs, there's a package. You have to be, because this is the first time, you must be connected to the internet for the package readout to, I think read Excel to install. Okay, so it will install by itself, and then you have access to it. So you have to click on the Excel worksheet. Is that okay? So double click on the Excel worksheet, and then it will take some time to retrieve it. And you see it over there. No, the Excel worksheet, the Excel access. So the CSV, we have to use a code to read it. Now, if you look over here, down, this is also very important. If you scroll down, you see first row as names. Please, are you looking over here? Okay, so when you get here, scroll down, you see first row as names. Remember the data we are reading, the first row is what? The names. So sometimes you have a data set that do not have names. If you don't untick this, it will read the first one as what? As the names. So you lose the first row. Now, alternatively, if you don't also take this for the data we are doing, it will convert everything into character. Because the first row will now be part of the data. Is that okay? So this is very important. So by default, it is ticked. Yeah. So you see code preview, library, read, Excel. So this is a package you need in order to be able to read. And what we are doing is the same as using read underscore Excel air quality data dot XLXX. So, and then view and so forth. So let's import. And there we have it. Air quality. 153 observations of what? 6 variables. So if you have been able to get it, let's look at the structure of air quality. I think there's a mistake. Not a mistake, actually. I don't want you to use this because there's air quality already in R. It's a copy with it. So please, let's name it air quality 1. So I want to remove this so we don't have any. Remember that you can also oh no, it's okay. Because the R1 is what? Small letter. So it's fine. Don't worry yourself. So it's okay. Do we all have the air quality like this? Okay. So this is how we read data into R. One way.
I'm sure it was really messy. About it.
biodata into a. Yes. So read each biodata as well. The same procedure. Yes. The same. Yes. So you browse. And you search for the invite. Yes. The invite. You can also save it as Excel. But the net ID is needed, so don't do it. Please, are we okay? Yeah. You may have, I don't know the stops up on the program. The one, yes, I'm able to connect to the staff, but I don't know why it works. It's working. Then, okay. So, I think okay, so, alternative if it's not connected, then it's something to do with is your undergraduate one of the ID number they gave you? Yeah, so I'm sure maybe the new one. One of you should remind me. Is that the email? Then I'll read the email. Please, are you done? Have you been able to read the ink biodata? Okay, so basically this is how you can also, when the data is online, you can also scan with the URL. Okay, so let's see. You can scan. Do I want to do this? Oh, because we. Okay, so you can read. Let me see if I can get something on GitHub. Okay, I think we should just move on. Let me make a comment. Shrimp, the salinity. Yeah. So I'll send you a link, okay, for this data. Okay. So this is a data set on something prawns, right? Okay. So the site, the season, it was called the sex, the salinity, temperature, length, and weight. So this is on GitHub. So this is something online. So how do I read it. Well, I need this, okay. When I copy this, so please just look at it. I'll send you the site or the URL, and then you can do it on your own as well. Okay. So you have to get it in raw form like this. There are several ways you can do this. You can use this, or alternatively, maybe that one will be better, is to select all of it, Control A. Okay, so when you do this, you copy into your clipboard. I can also read from clipboard. Is that okay? So you don't need even the reading that we were doing. You can just use the command and read from the clipboard if you have copied the data. Okay, so I copy this, and then I come to R. So let's say this is streams. So I'll say streams. And then I use read.table. So you can use, you remember the CSV file. We can use read.csv, but there's read.table if the data is table, right? So file, what file do I want to read from? It's clipboard. I'll send you this so you have, you can practice it on your own. So clipboard, but the spelling must be right, otherwise. So clipboard means check the temporal storage area of R and then copy whatever is in there. Now, then I go back to this data. Oh, not this. You see the first row is what? The names. So that's the header. So I'll provide a header and say header is what? True. Header is true. Which means read it and get the header. That's all. So streams. Now let me go to environment and look for streams. There it is. Oh, no, it's one. No, it was wrong. Because the data has CSV, I need to use read.csv. Look at it. Oh. Okay, so that's it. Okay, look. So it was a CSV file that I downloaded, right? Okay. So I can, so instead of table, I can do CSV. Oh, no. No. Let me go back. I think there are commas and so forth. Separator is comma. Okay, there's something is separating them, yeah. So I need to use separator. So sep is equal to, then I put a comma, like this. Okay, yeah. So now I have 7 variables. Okay. But you can also use CSV. If you use CSV, you have to also provide a separator as well. Yes. So just look at this. So you can practice this with the, let's say the inch bio as well. Just copy any of them. So that's another way of copying. This one, regardless of how the data is stored, whether even if it is in Word, just copy. But you have to check whether the data is separated. Sometimes they are separated by space, then that's okay. It will take it automatically. But you can also put the space in quotation marks. Empty space, yeah, and then it will do it. So let me do the inch bio. So instead of reading it from Excel, I can also read it this way. So inch bio, right? Okay, so this is the inch bio data. So I do Control A, it's like this. Then I copy Control C. You have to copy. So now the data is in what? The clipboard. Is that okay? Then I go to R. So I first check the net ID. So this is a header. So I must provide header is true. But because this is Excel, I don't need to provide a separator because they are already separated. The other one, they were together. You can't really see anything over there. Look at it. Everything is together, but they are separated by what? Column. Sorry, comma. So that's why I did it that way. So in Excel one, it's easy. I just come here, then I'll say inch bio. Let's say inch bio is assigned read dot, then table. I'll go and read it like this. Okay. So you see, it tells me file header. So by default, the header is false. So I just type file and then I put in what? Clipboard. Make sure the spelling is right. And then you can also read with the name as well. But that is if it is stored within that folder that R resides in. Okay. So you just provide the name with the extension. Okay, so that's another way. So there are so many ways you can use to read the data. Header is true, and then I run this. So we have a problem here. I think one of them is empty. Yeah, so to go around it, I'll use a CSV. That I think can overcome that, yeah. But I have a problem of it being one. So I think separator, it needs a separator. Let's see. Yeah. So now it's better because it's now 5 variables, 1011. Is that the case? Let's go and check. How many were they? No, it's 677. Something is wrong. It means it did not store it properly. Okay. So I see what the problem is. See, the names, right? The names are, when you are using these ones, it cannot read spaces. So look at the names. There's blue jail, but these ones. So that's what is causing the problem. Okay, to overcome this, I will just read the file. Please, are you with me? So I can read the file straight away with the file name. So instead of this, I'll just go and copy the name of the file, inch bio, right? .csv. But as I said, your R should be in the folder. Okay, so what you can do is that you go to session and say set working directory to source file location. And the name, the file should be in that folder. Okay, so inchbio.csv. Right. So here, .csv like this. I don't need separator. It will read it by itself. There we go. And you see now it's 676, exactly what we wanted on 5 variables. So these are very minor stuff, but it can be very distressing if you don't know your way around it. So you can use read.table2 to read the CSV or any other Excel as well. All you have to do is to provide the extension. So read.table is universal, while read.csv will only read what? CSV file. So, okay. What did you say? Read.
this. Yeah, but you have to check. You see, this is what I was saying. Your file is not in the folder. How is not in where you have stored it. So you have to go to session and say set working directory to source file location. And the data must be there. So if the data is there, now you can run this. There.
Yeah. So that's very important. The file and the data must be in the same folder. Otherwise, it cannot read it. The alternative is to provide it with a long file path. But that's not a good way to read it. Okay, so that's how you read data. Is that okay? Any question? Any question? So if you don't have any question, I move on to descriptive statistics. It's always a difficult thing teaching in the weekend because it's so long and it's you try to balance things out and so forth. But absorbing in 4 hours, yeah, sometimes I feel pity for you, but life must go on. So I need to go on, but on the other hand, I'm thinking whether to stop or. I said I'll give you 30 minutes to do exercise, but the exercise I haven't read it. So let's do it, and then I'll give it to you as assignment. Okay. So now we know what the R Studio is. We know how a data set is stored in it, right? Different data sets, how to retrieve them, how to read our own data into R, how to even select some observations, according to some conditions and so forth. Okay. Now, the next thing we do is how do we do descriptive statistics? Well, remember that, did I show you some publication from Statistical Service? I did. That's where we are getting to now. The graphs and the tables they've given, how do we get there? So that's the part of this course. Okay. So for descriptive statistics, remember we saw graphical ones, and then we have numerical descriptive statistics. So let's start with the numerical ones. Okay. So A, numerical descriptive statistics. Now, for descriptive statistics, in your course, you did measures of location, right, or central tendencies, mean, median, mode. Then you came to measures of variation, range, interquartile range, standard deviation, variance, coefficient of variation, right? Then measures of other central locations, percentiles, deciles, quartiles, and so forth. Right? Then you did correlation, right? And so forth, and so forth. So we are going to do all that here. Okay. So now, to get descriptive statistics, we can use what we call summary. Okay. So let's look at the I think we all have the air quality, right? Okay. So let's call air quality and check the statistics on wind speed. So this is it. So the minimum wind speed is 1.7. The first quartile is 7.4. What is this value? How would you interpret this value? The first quarter is 7.4. How would we interpret this?
Quarter of the data fall below the 7.4.
A quarter of the data. Good. Yeah. So a quarter of the wind speeds experienced in this town falls below what? 7.5. Which means 3/4 or 75% will be what? Above this value. So you see here, if let's say there are you are providing insurance for buildings and so forth, and you realize that 7.4, if you cut off, let's say if the wind speed is above 7.4 and it destroys your house and the insurance company is going to pay, then you see 75% of the time you are likely to have to pay according to this data. You don't do insurance like that. 75% is a lot. Do you get it? Yeah, so you may want to set it at, let's say, the third quarter or the 90. If it is the amount is so huge, then you want to push it somewhere the 99 value and so forth. So that's the importance of some of these statistics we deal with. What about the median? So the median is 9.7. What can we say about it? Yes. What can we say about the median? 9.7. Let's hurry up so that we can. Otherwise, we'll close at 5. Hurry up and let's go. Half. Okay, I've heard half. So 50% of the wind speed are below what? 9.7, maybe. We haven't checked the air quality. And you have to use a unit of measurement to communicate this. Okay? If it's statistics, whatever you are doing, it must be the unit. So communicate in such a way that whoever needs to take a decision don't have to struggle. So the wind speed is what? Miles per hour. Okay, so we'll say that 50% of the wind speed are below what? 9.7 miles per hour. Okay, and so forth. Okay. Now, what can you say about the distribution of wind speed? The mean is slightly larger than the median. So what can we say? So when we say analyze this data and you have these statistics, we are not saying that tell us the mean is 9.95, the median is 9.7, the maximum is 2. That one we know it already, it's from the table. We want you to be able to put interpretation on it. So you see, we took the first quarter, then we said 25% of the observations or the falls with, we are interpreting it. Okay. Now we see that the median, we can say that the mean is slightly larger than what? The mean. The median. Which means the data is what? The wind speed is skewed. Skewed to where? It's skewed to the right. Why? It's positively skewed. That's what the explanation. Yes, it's positively skewed. But why is it so? Majority of the observations. How do you know that?
The right side of the mean.
So you have to ask yourself, under what conditions would the mean be larger than the median? What will cause the mean to be larger than the median? Yes. When Yes, analyzing. You were calculating a mean. Under what circumstance would the mean be shifting towards the right? When, yes. Good. So there may be some unusually large value that would push the mean to the right, which means most of the observations will be on the left. So the median will be where most of the observations are. Is everybody okay with it? So, but this one is not so profound. It's at 9.7 and 9.95. So there's just some large observations, right? So to visualize this, I'm going to plot a histogram or maybe a box plot. Okay. So let's look at a histogram. So histogram is haste. Haste x will be equal to this. I'll give you a video on this plot, so I'll be just quick. Just this is for visualization. Okay, so let's see how this looks like. So you see, as I said, the difference is not that much. So if you look at if you look, it says it's shifted a bit to the right. If you look at this, you realize that the tail is towards the right. The right tail is a bit slightly longer than the left. That's why the mean is a bit higher compared to the median. Is that okay? When we do this, you realize that we are putting interpretation on it. We are not really calling the numbers by itself as you see in the table. All we are saying is that the mean is slightly larger than what? The median, signifying that the data is right skewed or skewed to the right or positively skewed, which means that some observations are slightly larger than majority of the observations. That's the interpretation. That one, you are not repeating what is in the table. Okay. Now let's move on. Now I want you to install the package called Psych. Psych. So this one. So quickly install it. There's a function in it called describe and describe by. It gives elaborate statistics for us to, so all these skewness that we are talking about, we can now get values for it and look at it in terms of it being positive, skewed, and so forth, and even kurtosis. So psych, P-S-Y-C-H, psych. Are you done? Like psychology. And then click on install. Click on install. Okay, so once you click on install and it is done, when you come to your packages, you can search for it and then click on Psych. Okay, now, so there's a function as I call describe. So there's a bit of functions called describe. So I start typing describe. So there's describe and describe by. There is even describe data. But they are using psychometry, right? But it has uses in other areas as well. So let's look at describe. So describe gives us basic descriptive statistics. So usually I'll tell you, describe the data or describe this function and so forth. Then I mean you should do question mark and go and check what the description of the function is or the data is and tell me what it is. Okay. So let's look at describe. It says the usage. So you come to the usage, it will tell you how to. So you see here na.rm is already true. So even if the data has missing values, you will still get what? Your results. Good. Okay, so this needs just x. So I'll say x. Then let's call air quality. And then we were looking at what? It was wind. So let's see how this is. We run it. So look at the extent of descriptive statistics that this gives us. So first of all, we get to know the sample size. So there are what? 153 observations in this data. The average is what? 9.96. I'm not saying when we say interpret, do what I'm doing. I'm just calling them. When we say interpret, then you are just, okay, there were 153 observations of wind speed that was recorded. The average was this. You remember the skewness. You see it's positive, but it is quite small, not so different from zero, right? Okay. Because of the way it looked like, the histogram. Then there's keratosis. This essay keratosis is almost normally distributed. Is that okay? Because if the SS keratosis for normal distribution is 3. This is measuring the excess, so it is just 3.03. So it's almost close to normality. And that is true. From the histogram, it looks like what? A normal. And so that's the sort of interpretation you put on it. See the range, 19. Standard deviation is 3.52. We can't really say much because all we know is that it must be small. The larger it is, the more dispersed the data set is. But when we begin to compare with other groups, then we'll be able to talk about variation in those. So let me go back to the air quality data and see the way it looks like. Do we have any categorical data? No. Okay. So now let's look at, is it time? No, not yet time. The other data was inch bio, right? Okay. Do you all have the inch bio? Good. Okay. Now let's look at the head of inch bio. Okay. So the fishes have ID, they have net ID, they are species, right? Good. So now I want to check TL is the total length. So for example, if I want to advise fishermen as to which species they should buy, if they want longer fishes, which one should they go for? Then you see this one, I need what? Some descriptive statistics per species. Is everybody okay with this? Yes. Good. That I cannot just use describe. But remember we had described by the group. Okay, so we can use that one. So let's see. So describe by or describe by. Any of them will work. So this one, you describe by S and the group. Okay, so let's see. Let's copy this. And then we paste it over here. So let me write some notes so that when I send it to you, it will. So the comment is that obtain descriptive statistics. As for this, in your exam, I'll bring some. obtain descriptive statistics on the total length of fishes per species. And comment on your results. So how do we do this? Well, we will use describe by. So this one we want to get it per species. So I call inch bio. X will be what? The total length, right? Which group? To be inch bio, I want what? Species. Is everybody okay with it? So we are saying that construct confidence, not confidence interval, but descriptive statistics for the length of the species per group, okay, for each species. So let's see. I run this, and there we go. Okay, so let me try and see. I want to get all of them in a straight line. Yeah, it worked. So this is it. This is the length of the species. So yellow perch. So now you can begin to talk about them. So even though you are interested in the length, look at n, the number. So you realize that blue gill are in the majority, right? So some of these you can use, let's say, percentages. Blue gill, largemouth, 228. Oh, so it's largemouth. So you can get it, I think you know there are 1,340 of them. And so you divide them by percentages and talk about it. Is that okay? Yeah, so that's also one way to do this. So I can look at, I think the highest one is 228 divided by 1340. So I think about 17% of the species are what? Largemouth. Okay, and so forth. As for tadpole, they are only 6. Okay, so you can look at it and which ones are in the majority, which ones are just some few, and so forth. Okay. Now let's look at the average length. So there we have different species. You are not going to call the length of every species. You look at those, the highest, middle level, the smallest, right, in terms of length. Okay. So when we look at this one has 280, then you have 140, 61, 74, 298, largemouth bass. So you know the large mouth bass, they are the longest, right? On average. Followed by what? The black crappie. And then we have the tadpole. Yeah, they are in that's the smallest in terms of length. Or the shortest, right? Because this is length. And remember, the tadpoles, I think they are now forming to become fish, right? So it's understandable. Yes. It's a TL. So there it is. Inch bio TL. That's the data. And they are being grouped by what? The species. Oh, the mean. I'm looking at the mean. Good, okay. So the mean, if you look at the largemouth bass, they have what? They are longest in terms of length. and the child poles are the smallest. Good. Then now you can look at the standard deviation, because this one we have different species. You see which ones are more variable in terms of their length. Okay, so you see that the pumpkin seed, they are not the longest, right? In terms of, but look at its variation, it's quite high. Which means for such fishes, some can be very short, others can be so long. Is that okay? So that's the conversation you write around it. Okay, you compare and then contrast. Look at this one, the yellow page 2. That's 83, quite high. So and so forth. Then of course you can look at the median as well and talk about it. Then the maximum, that will also be key. So the maximum for the black cap is 33330. This 239. Look at the blunt nose, only 84. Data 61. Oh, then the large man, 429. So these are some of the things. Of course, the minimum too is there. You can talk about it and so forth. Skewness. Some of them are positively skewed, so then you interpret it, which means for such fishes, most of them will be what? Their lengths are short, then occasionally you have what? Very long catches, or fishes that were caught with all, that have long length, so to speak. Then you have those that are negatively skewed. So for such species, most of them are long, and then occasionally you have what? Very short fishes caught with what? Short length and so forth. So that's the sort of meaning you put into such data set. Is everybody okay with this? Okay. So that's it. So this is very important, the describe by. We can also get a descriptive version which is plot by using the negative kurtosis. So remember the kurtosis, we are measuring SS kurtosis. So that of the normal distribution is 3. So if the kurtosis is less than 3, we'll get negative.
But the previous one was 0.03.
Yes, so it was slightly larger than the normal distribution. Now let's see. So what we have done here is the numerical aspect, which means we were able to group them, the species, and then we were able to talk about them. We can also get a descriptive version, which is using a box plot so that they are side by side. That also helps in visualization. Okay. So to do that, we can use the box plot. As I said, I'll send you a video on all these. Please take your time. We can't do all this during the weekend. So formula will be, the data is inch by. What we did was to do TL on species. So this is tilde. So tilde, this sign is tilde. You find it on the top left hand of your keyboard. So inch by length on what? The species. And this is box plot length per species. I think distribution of length. Distribution of length per what? Per species. Okay, so let's see. There we go. because I have to increase my length, my font dim so that you can see. So these things cannot go there, right? Okay, but if I pop it out, you will see it. And I can even color them. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8. So color, I can just sample color from the rainbow. So 8 of them. So the rainbow colors, you can sample colors from it to do this plot, and it looks like that. Nicely done. So if you are interested in fishes with long length, then you'll be considering this species, right? That one. So this essentially is the largemouth bass. So you see that one, most of them grow with what? High length, and then occasionally you have what? Some ones that were caught with what? Shorter length. Is that okay? So the outliers are what? Short. This one too display the same. But look at this. There is I think this is the tadpole or the other one. So this is an outlier. Even a large outlier, right? Which is even not compared to even the short outliers for the black cappy. So graphs like this also are very useful in comparison of groups like this. Are you done with the codes? Because I want to pop it out like this so that we see. So this is the graph. So you see that the black cappy, if you look at the data, they have long length. This one to the largemouth bass. So blunt nose, this is an outlier for it. It's not even close to an outlier for this one. The tadpoles, they are almost apart. So, all right. So let me get out of it. Okay. Do we have any questions? So that's it with these descriptive statistics. Okay. So when you pop it out, when you zoom it, you will see the various, even though all of them are not able to be written. Now, we can also write it, we can slant it so that you see it, and even reduce the font. So this one, if I want you to see, I can go in and reduce the font size. So in R, you have absolute control. Sex.axis, let me use 0.8. If it will work. Yeah, so I'm just reducing. So by default, it's 1. Okay, so you see it's now becoming very small. Yeah, and then when I do it like this, you see all of them. Okay, so you have absolute control about how things are. Now we can even slant it so that it's written on the 45 degrees line. So yeah, so that's it. If you want to see each of them. I think 0.5 is so small that you can't really see. I can go in. So sex.main will be for title, sex.asis, and all that.
Prof,
Yeah.
please, we appreciate if you take again how to interpret the box plots.
The box plot. Okay. So you see, over here is total length. Let me go to the other one. If you are there, can I pop it out?
Yes.
Okay, good. Now, so the interpretation, remember that you have to advise fishermen which species they should go for. So of course, if it is fish, the longer it is, the more likely it is to have way more. It's not always the case, but if they are of the same species, then if it is long, it will maybe have, but some are very long like snake, and then it doesn't have any meat. Is it meat? Like flesh, I should say. Fish certainly cannot be meat. Okay. It doesn't have flesh for you to eat, only bones and so forth. Okay. So here, we are interested in the one with the long length. So which species will you go for? Of course, the one that the box is so high. Remember the boxes, this is the first quartile, this is the median, this is what? The third quartile. Any values over here are outliers. So majority of the data set are here, then these are distinct. They are the small ones. So, but the small one, 200 is small. Meanwhile, this one, they don't even get 200. So, for a fisherman, I won't advise you to go for this one. So, I will rule these ones out completely. We will come back to this in your inference. This is what you did in test of hypothesis, for example, analysis of variance. This is it. If you have to advise and for them to choose one, then it means you have to test to tell us which of these on average is the highest. Okay. Pictorially, we would have gone for this, right? Because if you look at the median is almost, but it coincides with this one. So we can only do so if we perform a hypothesis test. But now we are just using visual representation to make a decision. Right. So this one, if I take 200, all these will be out, right? Then the competition will be between largemouth and what? Black cap. So that's it. Now, if you want those whose lengths are very small, then the competition is between this, that, and that one. And it's difficult to choose one. Well, this one seems to be very low, and so forth. So that's it. And another thing, the longer the box in terms of its width, the more variable the data set is. So if you look at the black crappie, they seem to be what? Close together. So it means that if you are rearing such fishes, the length will not differ from each other so much. They all grow almost the same.
How do you interpret, not the entire set, I'm taking just one box. I'm taking one box as an example.
Yes.
And I think you have the line is the median.
The middle one is the median.
The median.
Yes.
So if it goes up or comes to the bottom of the box,
Yes.
or at the middle of the box, what sort of complication are you providing? If it is at the top, as you see, mostly some of them are at the middle, some.
Which one? These ones? No, this is the whisker. So the whisker, usually, I don't want to go to the mathematics, but I'm sure you did this in your descriptive. Is it descriptive? Yes, you did descriptive statistics. Good, yes. So this one, we construct it, you know that we call this the interquartile range. If we subtract this from that one, so this one, if we go here, is around 350. This one is around maybe 280. So 350 minus 280, 70. So the interquartile range is 70. Now, if I multiply that by 1.5, and I add it to this, I'll get this whisker. Then if I subtract it from this one, I get this one. So that helps me to now determine which measurement is an outlier. Okay, good. Now, so this one, if you look over here, it's like you don't have a lower whisker. Why is this so? It's because around that, the values are almost the same. So when you draw the first quartile, it's almost like the whisker and so forth. So the larger it is, so if you look at this one seems to be more dispersed, even though they don't have outliers. But the values are more dispersed around each other. Followed by, but if you look at the range, and those are the, what do you mean? The disadvantages of using range. Okay? So if I'm using the range, I would say this one will have the longest range. Right? Okay. But if you look at it, these ones are more dispersed within themselves. Yeah. And so forth. So that's it. So box plots are very important especially when you are doing comparisons. Yeah, it is used before you do any test. You need to construct a box plot to do this. Okay, so that's how that is done. We are left with some graphs. As I said, there's a video. I'll send it to you. So we'll start first with pie chart, bar chart, histogram, box plot. There's line graphs to check correlation and so forth, and even curve fitting and so forth. So I'll send it to you. But I think now you are in a position now to do my assignment. You can take it home. I'll send it to you on your WhatsApp. Yes, so I think we can close. Now it's been enjoy the rest of the